Hey everyone, it's Mr. Carr again, and today we're going to be starting Unit 2 out. And today's focus is called 2.1, Transformations and Congruent Figures. Okay, so what we're going to be looking at is just a general definition of what does it mean, what is a transformation, what does it mean, and then also what creates what's called congruent figures. Okay, so our two main ideas, what are transformations, what are congruent figures? This is a few diagrams here of types of transformations. Okay, the first one, you can kind of see, here's how it's working. I'm going to go ahead and label this now a little bit. There are some terms here called a pre-image and image. And what that means is that a pre-image is going to move and turn into an image. So pre-image is the starting shape, the image is the after. So if I look at this first one, you notice how I've got A, and then this is called A prime. And then B and B prime and C prime, okay? So those are all primes there. The prime is for the image. We use prime notation to show the image. So this is the after, okay? So I'm going from here to here. This is like a sliding down. It kind of goes down and to the right. That is called a translation. Okay, in this one, you can see here's the pre-image, ends up over here. I bet you can probably figure it out. That's called a reflection. Okay, it's a mirror image. And the last one is this one. So it's going from here and spins in that quarter of a circle. That is a rotation. So what is a transformation? Okay, a transformation is a movement of an image on the coordinate plane. So we are moving it in some way. Okay, the ones we're focusing on right now for this part is what's called a rigid motion. A rigid motion is a movement that does not alter the size or shape of your image. Another term you might see for that is called an isometry. I don't know why we have all these different definitions. We just do. Okay, so isometry, rigid motion, those are all mean the same thing. It means that the shape from before and after are exactly the same. So take a look at these. You can see here's my prime there. Got Nike and Nike Prime. So what type of transformation is that? You can see that it's mirror image there. So that is a reflection. Okay, this one, here's my prime shoe here. This one looks a little bit tricky. Some people are going to say like, oh, isn't it rotating around like this? Not quite. Like if you have it on a piece of paper, try physically rotating this. It's not going to quite look the same way. Okay, what this actually did was it actually reflected again, but it reflected on an angle. This is another reflection here. Okay, but it's a reflection on this angled line instead of a horizontal or vertical or horizontal line. Okay, is this an example of a rigid motion? So I'm going to pause it right here and let you kind of tell me what you think. Okay, now that we're back, here it is. It is a no, because even though the shape is the same, the size changed. Okay, when that happens, that is no longer a rigid motion. It has to be the same size and shape. So if we change the shape but not the size, not a rigid motion. We change the size but not the shape, not a rigid motion. It's got to retain both. So this is a vocab from the future. So this is what's called a dilation. We'll see this again in Unit 3. So this is a transformation that stretches or shrinks an image. All right. So that's our introduction to transformations. The next few lessons, we're going to go over each of these right here, translation, reflection, rotation. We're going to go over each of these on each lesson for each day on each of these. So that was awkward. All right. The other part that we're going to talk about today is what's called congruent figures. So let's start with this. What symbol is used to mean congruence? honestly, we should probably start with this. What is it to be congruent? Okay, so let me define that real quick. So congruent is when it's pretty much another name for our rigid motions. It is when we have an exact copy of a figure, figure, line, segment, angle, things like that. So it needs to be an exact copy of that. So what symbol do we use to mean this? It's this kind of a symbol. It's got an equal sign, a little squiggly above it. That means congruent. Okay? So the figures below are congruent. We're going to identify the following. When we have congruent figures, we actually have all of their angles, all pairs of congruent angles, and all pairs of congruent sides. Okay? So if two figures are congruent, we have things that match up for everything. So we look at this angle P right here. You notice how I'm using 3 arcs there. So in the other triangle, that's going to match up to angle L, because that's the other one with 3 arcs. Angle Q has a single arc, so does angle J. And then angle R has 2 arcs right there, just like angle K. Corresponding sides, okay? And you know what, I didn't use this term, but corresponding is just referring to what matches up between the two shapes. So when I look at my angles, that was easy. My sides might be a little bit harder, but you notice how I'm using this here. When I look at my sides, here I have a single tick mark that's going to match up to that single tick mark. So that means that PR and LK match up. Okay. If I'll do yellow for this one, I've got PQ has 2 tick marks, so does JL. So that side length is JL there. And that leaves me the last one, which is 3 and 3. So when I want to show that two line segments or sides are the same, they're congruent to each other, we just keep adding tick marks until it matches up the number. Okay, 1 matches to 1, 2 matches to 2, but 1 and 2 are different from each other, and so on. So that leaves me with JK as the final side length there. So that's what we're looking at. In 2 pairs of triangles, we get 3 pairs of congruent angles, 3 pairs of congruent sides. The last thing is what's called the congruency statement. This matters. What makes the difference here is that it needs to be in the correct order. And the easiest way to look at that is look at the angles. Since I went P to Q to R, okay, P is angle that matches up to L, Q is J, and R is K. Okay, so I'm sure you hear that in the background. That's fun. Okay, so when you look at this, it has to match up. Whatever the first 2 letters are the 2 angles that are congruent to each other. The middle letters are the second angles that match up, and then the third also have to match up. And it doesn't matter how you name it as long as you're consistent with that. So if I look at this one, QPR, Q matches up to J, P matches up to L, and then K still matches up to R. So I did that in a different order, but it's okay as long as they match up to each other. So when we can use that is, we start looking at, if I give you congruent figures, we can start figuring out a couple of things from that. So for example, the triangles below are congruent. How would you describe the figures? So is ABC congruent to XYZ? So what I'm going to look at is A matches up to Z, B matches up to X, and C matches up to Y. Okay, so when I look at that, A and Z need to be in the same position, which they're not. So that one's gone. Okay, next one says angle BAC. So BAC is this angle here. All right, YZX. YZX is this angle here. Yep, those are congruent. Those are the same angles. Okay, one thing I forgot to mention too, another way of showing angles are congruent, I could also put tick marks on these little arcs. And then if I have 2 tick marks and 3 tick marks, just like side lengths. So just be aware of that if you ever see that. AB, so that is 3 tick marks here, is congruent to XY. That is false because that's 2 tick marks. So that one's no good. Triangle BCA. So I've got orange, red, yellow. XYZ, orange, red, yellow. We're good with D. Okay, so B and D are the 2 that work here. In the diagram, QRST is congruent to WXYZ. Find the value of X. All right, so X, I can see is right here, is 5X plus 5X plus 5. That is an angle W. When I look at the other diagram, you might have a certain assumption that, oh, it looks like it's flipped or whatever. Don't just jump off that though. Look at this statement. W is the first letter, so is Q. Q is 65. So if I want to find the value of X, I need to say that 65 equals 5X plus 5. Because remember, based on my congruency statement, I know that angle W and angle Q are congruent to each other, which means they have the same measure. So I'm able to set 5X plus 5 equal to 65. Okay, so I got 60 is equal to 5X, divide by 5, and 12 equals X. And that's it. Okay, so that is our lesson for 2.1. Remember, we introduced the idea of what are transformations, and we talked about what are congruent figures and how are some of those important pieces of that. Okay, so we will continue these on with the future lessons. I will see you later. Enjoy the rest of your day.